we were talking about Bohr's model and in reference of hydrogen atom only. And we said there are stationary states which are called energy states or allowed energy states. Okay. And then electrons can move to higher energy state if we provide energy to electrons. So it is important to remember that when electrons move outward, they gain energy, they absorb energy. This phenomenon is required to explain one very important point, that why the energy of electron inside the atom is negative. Okay? And reverse will be obviously when they move from higher energy state to lower energy state. In that case, they will release energy. Emit energy means they will release energy. The n equal to 1 state in case of hydrogen is known as ground state also. So stationary state is also known as ground state. So if anywhere it is written ground state, and in Bohr's atom it will be hydrogen or hydrogen-like species only. So ground state in these cases will be n equals to 1. This was the summary of all the lines which could appear based on which level they are falling. They will be called Lyman series, Balmer series, Paschen series, bracket series, n equals to 5 is Font series. There is another one, n equals to 6, which is not in CBSE, but from NEET and JEE perspective, Humphrey series. Okay? You don't need to remember it if you're not planning for NEET or JEE. That is n equals to 6. Next, related to Bohr's model, angular momentum, you need to remember that for an electron of mass m, you know the mass of electron, moving in a circular path of radius r around the nucleus, angular momentum will be given by mvr. This is something you have studied in physics, that angular momentum of any body in a circular path is given by mvr, where m is mass, v is velocity, r is radius of the circular path. So this formula you need to remember. There will be either questions which will utilize that, whether if we increase the radius, means in higher orbit, angular momentum will be higher or lower. You will use this formula. Angular momentum is proportional to radius if other things are common. Okay. Although velocity is not same in both the orbits, if we are talking about two orbits, it will be different, and I will be talking about the formula you can use to give the velocity of the electron in an orbit, specifically for JEE. The frequency of radiation absorbed or emitted is given by nu equals to delta E by H. If you see, this is very much similar to E equals to H nu. And the same thing is being utilized here as delta E, because this is the energy difference. So in case of Bohr's model, nu will be given by delta E by H. Why? Because in Bohr's model, there is transition of electron from one orbit to another orbit. And that's what Bohr said, that if any electron moves from any higher orbit to lower orbit, it will release energy. Means how much energy it will release? It will release energy equal to the difference. If here energy is E1, here energy is E2. So delta E will be the difference, E2 minus E1. This much energy will be released. So energy released here is delta E. So that's why delta E equals to H nu, where H is same thing. So nu will be delta E by H. This is known as Bohr's frequency rule also. Angular momentum, according to this theory, angular momentum which we talked about, MVR, is quantized. Angular momentum is given by MBR, but this theory says it is quantized, means it can be in the steps of h by 2 pi. So if n is equal to 1, angular momentum will be h by 2 pi. If n is equal to 2, then it will be 2h by 2
H
pi.
by pi.
Yes, h by pi, 3h by 2 pi, and so on. It means no possibilities of angular momentum in between. No other possibilities. So angular momentum of the electron is quantized because it can have only some specific quantities. If h upon 2 pi is x, then it means x, 2x, 3x, etc. According to Bohr's model of hydrogen atom, now these are the points which are asked also as 2 marks question, and these points are used also. The first point is the stationary states of the electron are numbered as 1, 2, 3, etc. And these are known as principal quantum number. In your previous grades 9, 10th, you know that these are represented as K, L, M, N, etc. Principal quantum number.
Sir, these are the shells or the orbits in which the electrons revolve, which
Yes,
was said
these
by
are the
Neil.
orbits.
Okay, sir.
Shell word we will be using in quantum
Yes,
mechanics.
sir. Yes, sir. KLM and shells.
Yes, same thing we will be referring to as shells there. But shells are 3D, orbits are 2-dimensional only.
Yes, sir. Yes, sir.
The radii of the stationary states are given by a formula. This formula will be used extensively. Okay. High possibility that you will get a numerical based on directly or indirectly on this formula. N stands for the orbit number. So for example, if it is asked what will be the radius of first orbit, so R1 will be 1 square A naught, where A naught is 52.9 picometers. So A naught is 52.9 picometer. It means this is the radius of first orbit of hydrogen. Because that's what you will get. R1 will be 1 square into 52.9. That is 52.9 picometer. And R1 is radius of first orbit.
Sir,
What is the value for picometer? 1 picometer?
So 10 to the power minus 9 meter.
That is nanometer. 1 picometer is 10 to the power minus 12 meters.
Okay, sir.
Thus, the radius of the first stationary state means orbit or energy, called the Bohr orbit, is 52.9 picometers. Next point related to Bohr's. Energy of an electron in its stationary state is given by En equals to minus RH 1 by n square, where RH is Rydberg's constant. Yes, what is the question?
So I wanted to ask related to the formula of radius.
Okay, what's the question?
So isn't the formula like उसमें divide by atomic number नहीं होता है? Like this
Here
is
it is for hydrogen atom only.
Yes, sir, but other hydrogen like species में like lithium ion दे दिया तो उसका तो हम atomic.
We will be talking about that. Okay, because here I am mentioning only hydrogen atom. The formula will be this one.
Okay.
Energy of an electron. So if I have an electron in third orbit, so n will be 3. So I will use this formula. RH in this case is given by 2.18 into 10 to the power minus 18.
Sir, is it a constant, sir, here, RH?
This is constant. This is constant.
Okay, sir.
So RH is Rydberg's constant, and its value is 2.18 into 10 power minus 18 joules. You just need to change the value of n.
So, but RK value to 109677 centimeter thing.
That is for wavelength, because unit has changed. Here it is in joules. right? So in
सर
joule,
दोनों में अगर
the
आर
value
आर लिखा रहेगा तो फिर
you will use accordingly, whether you are calculating joule or you are calculating wavelength,
Sir,
wave number.
in electron volts, it is 13.6.
Yes, in electron volt it is 13.6. Okay. In joules, and you can convert it into electron volt. You need to just divide it by 1.6 into 10 to the power minus 19. It will be 13.6 electron volts. So it depends what units you are using. The Rydberg constant will change if you change the units. If you are using it for wave number, then it will be 109677 if you're per centimeter, right? So RH for wave number, it will be 109677 per centimeter, or 1.09677 into 10 to the power 7 per meter. Because per meter you will multiply it by 100, it will be like 10967700 per meter. So instead of writing, if you are using this unit per meter, instead of writing so long, you write 1.097 into 10 to the power 7. You just round off up to here. If you are using it for calculation of energy, then it will be 2.18 into 10 power minus 18 joules or 13.6 electron volts. Okay, with practice, it will become easier which one you will be using. The energy of the lowest state, also called as ground state, I told you n equals to 1 is ground state in case of hydrogen, is E1 equals to minus 2.18 into 10 power minus 18. This is RH. 1 divided by n square, n is 1 here. It means the same will be the energy of the first orbit of hydrogen with a negative sign. The energy inside atom will always be negative. I'm talking about energy, not energy change. Energy change can be positive or negative, depending on whether the electron is moving from lower energy state to higher energy state or higher to lower. Energy difference can be positive or negative. But if I am talking about energy of an electron, that will always be negative. One important concept here you need to understand, that if in chemistry and in physics it is opposite. So I'm talking about only chemistry perspective. If you have a system, I am calling it a system. This system can be any machinery. Okay, this system can be atom. So if energy is provided to the system, it is positive. Means if system absorbs energy, it is positive. If work is done on the system, which, and this is something we will be using in thermodynamics chapter 6. So whether it is energy transferred to the system, work done on the system, it will be positive. If energy is released from the system or work is done by the system, it will be negative. Work will be negative, energy will be negative. Okay. Both have unit as joule or electron volt. This convention you need to remember. Otherwise, there are high chances that you will be making mistakes in the sign of energy change. If you remember this convention and write it down somewhere, if it is in the system, it is positive. Means here absorption of energy. Here energy is released. or emitter, negative. Why this is important? This is important because if I am considering the electron is moving from one orbit to another orbit, say from n equals to 2 to n equals to 4. If electron is moving from lower orbit to higher orbit, lower orbit has low energy. When you will provide energy to this, then it will move to higher energy level. And this is something you can understand, that to remove an electron from atom, what you need to do? You need to provide it energy. Then only you can remove the electron from the atom. And that is called ionization. So for example, if I provide energy to sodium, sodium will get converted to sodium ion and one electron will be released. It will come out of the atom. So here you will provide energy to atom. And when you provide energy, it is positive. Okay. So suppose electron doesn't come out, rather it moves from lower energy state to higher energy, and then higher it can go out. Can go out of the atom. If it goes out of the atom, we say it has ionization, and in that case, n is infinity. Okay. So n is considered as infinity because the atom does not have any hold now on the electron. Means force of attraction is so low that electron can be considered as outside the scope of the atom. So electron is outside the scope of the atom. So n is infinity. It is not in the atom. N equals to infinity. So in this case, if we are moving from n equals to 2, n equals to 4, system absorbs energy. It means delta E will be positive.
Sir, I have one doubt, sir. As you said, sir, here there is a gain of energy, so delta E becomes positive. But sir, like when you were saying, sir, when we move from higher orbit to lower orbit, at that time, is there a loss of energy? Like, is energy released in that case?
Yes, yes.
So, sir, in that case, energy becomes negative, the delta E.
Energy will be released, so it will be
Yes, sir.
negative. So if this is n equals to 4 and electron moves to n equals to 2, the lower energy state, okay, the
Yes, sir.
energy will be, delta E will be negative.
And sir, can you once again please explain this n equal to infinity part, sir? I couldn't understand
N
this
equals
thing.
to infinity is, you will understand when I explain it through formula. Okay.
Okay,
I'll
sir.
explain.
Okay, sir.
Now, now there is a question which appears as, conceptual question, that why do we have the energy of electron as negative inside the atom? The answer is, the lowest possible energy outside the atom was considered as zero. Initially by scientists, in the environment, normal environment, whatever was the lowest possible energy, that was considered as zero. Because there was no possibility of energy below that level. So that level was considered as zero. This is something to, if you compare it with temperature scale, freezing point of water is considered as 0 degrees Celsius. So this is what we considered. We could have considered freezing point of alcohol as 0. In that case, the value of freezing point of water would have been different. So suppose we would have considered current 10 degrees Celsius as 0. Suppose. In that case, the freezing point of water would have been minus 10 degrees Celsius. Is this clear or not? If we had considered current 10 degrees Celsius as 0 level, then because freezing point of water is 10 degree below this level. So 10 degree below this level would have
Yes.
been minus 10 degrees Celsius. So in that case, freezing point of water would have been minus 10 degrees Celsius. That is what happened in this case also. Scientists had already considered 0 joules energy as the minimum possible energy. But when atomic energy was calculated, means intra-atomic particles energy was calculated, it was even lower than this value. So that's why that has to be negative. So that's why the energy of electrons inside the atom is considered as negative. Otherwise, there is no significance of negative energy. Here it is negative because we have the reference here at n equals to infinity, energy as 0. Okay, and you will see that through formula also. One more thing which I'll explain, that how you will get this as negative and this one as positive when I explain it through formula. For now, you need to remember that energy of electron inside atom is always negative. When electron absorbs energy, it is positive. When it releases energy, it is negative.
Sir, can you please show the previous slide?
That was I have raised. Okay. If you're talking about previous to this one, I can show, but that one I have
No,
raised.
sir, the convention one in which you.
तो diagram वाला.
Okay.
Yes, sir.
Anyway, I'm going to explain that in a different way. Okay. Now consider this formula. Energy of electron in its stationary state is given by this one. If I have n equals to infinity, it will give me 0.
Yes, so infinity gives us 0, 1 by 1.
Right. So this
Yes.
formula also complies with the convention that the energy just outside the atom is 0. That is what scientists had already considered. And inside the atom, it is negative. If you consider any value of n other than infinity, you will get a negative value. Means inside the atom, the energy is always negative. Now with this formula, if you are providing energy, and we say that if it is moving from n equals to 1 to n equals to 4, say, then we say that we have to provide energy, then it will move to higher energy state. And in a higher energy state, we said that it will absorb energy to go into higher energy state. We provide that energy, it will absorb that energy and will go to higher energy state. So calculate delta E. What will be delta E in this case? Final minus initial. Difference is always final minus initial. It is never initial minus final. Okay, if we have to consider the correct sign, it is always final minus initial. For example, initially you have money 10,000 rupees and after you have 12,000 rupees. So what will be the difference? Difference will be 12,000 minus 10,000, means 2,000 you have more. It will not be 10,000 minus 12,000. Final minus initial always. So delta E in this case will be E4. E4 will be minus RH 1 by 4 square minus E1. E1 will be minus RH 1 by 1 square. Okay. It means it will be plus.
Sir, we'll take common RH.
If I take RH common, then it will be 1 by 1 square minus 1 by 4 square. Is that correct? Because 1 by 4
Yes,
square
sir.
is with
This
minus,
minus will come afterwards.
sir.
Yes, sir.
right? It means it will be RH 1 minus 1 by 16. That is 15 by 16 RH, and this is positive. Delta E comes out to be positive. So this convention you need to remember, and you will require this convention to check that you are not making any mistakes. Sometimes, even if you know that energy will be absorbed, the answer due to calculation mistake can come negative. So you need to check that your answer should be positive here. And why it comes positive here? Because when we are moving from first energy state to fourth energy state, we will have to provide energy to the electron
Sir,
so that it can move to higher energy level. To move to higher energy level, it will absorb energy first and then only it can go to higher energy state. Yes,
so then we can use this formula simply like RH bracket 1 n initial square minus 1 by n final square.
yes. To calculate the difference in energy, yes. So you need to remember that delta E should be as per convention in chemistry. Whenever you provide energy to the atom or atom absorbs energy, it will be positive. If energy is released, it will be negative. So for n equals to 2, second energy state, energy will be, it will be E2 not E1, 1 by 2 square. So this much will be the energy of second orbit, energy of electron in second orbit. When the electron is free from the influence of nucleus, the energy is taken as 0, means at n equals to infinity, or you say E infinity is 0. Why?
So
Because
it
E
means
infinity will
outside the
be
atom.
minus RH. Yes,
Okay,
1
sir.
by infinity square, which will be 0. Means at that time, principal quantum number will be infinity. It means it is in ionized state. Electron has left the atom. Next, this is something what you were talking about. Bohr's theory can also be applied to ions containing only one electron, similar to that present in hydrogen atom. For example, helium atomic number is 2. So it is 2He4, means 2 electrons. But if it loses one electron, it will be He plus. This will also follow Bohr's theory. The formula will be slightly different, but all hydrogen-like species. What are hydrogen-like species? Having one electron only. Helium has 2 electrons, He plus will have 1 electron. Lithium has 3 electrons. Lithium 2 plus means 2 electrons lost. So out of 3, 2 lost, it will have 1 electron only. Beryllium 3 plus. Beryllium has 4 electrons. But after losing 3 electrons, it becomes beryllium ion B3 plus and has only 1 electron. So all these have 1 electron. These are hydrogen-like species. These will have similar formulas. There will be slight difference. Now here you will have Z. It is atomic number. Z is atomic number of the species we are talking about. If we are talking about He plus, Z will be atomic number of helium. Okay, that is 2. For lithium, 3. For beryllium, 4.
Sir, these are for elements other than hydrogen.
Other than hydrogen, but hydrogen-like species means they must have only 1 electron, similar to hydrogen. Then we can use the formula, but instead of having only 1 by n square, now we have Z square by n square. That is the only difference. Earlier it was En equals to minus RH. RH is 2.18 into 10 power minus 18, 1 by n square for hydrogen. And if you remember this one, this is applicable for all, including hydrogen, because for hydrogen, Z will be 1, atomic number is 1. The same thing. So it will get converted to the original formula. So I suggest that you always remember this formula. It is applicable for all hydrogen and hydrogen-like species. For hydrogen, Z will be 1.
Sir, can you explain this one electron thing, sir? I'm unable to understand, sir. In which regards are you speaking of one electron?
And sir, can you speak loudly because your voice is very low?
My voice is very low.
No, sir, it is fine, sir.
No, sir,
It is
it's fine.
absolutely fine.
I think you can increase the volume. Might be that your volume is low.
नहीं sir, मैंने full है volume.
Sir, but
Okay,
can you please explain for
if
one
you
electron?
if you score 10 on 10 in next 3 tests, I'll give you a good headphone. Is that clear? The condition is you need to score 10 on 10 in next 3 tests, then I'll gift you a boat headphone.
Yes, sir.
Okay. Okay, what I am explaining here, this formula is applicable if I am writing only En equals to minus 2.18 into 10 to the power minus 18, 1 by n squared. This is applicable for hydrogen. Okay. And hydrogen has 1 electron only. What Bohr said that although this formula is for hydrogen, if we want to apply this formula for hydrogen like species having 1 electron only, how can other species have 1 electron only? Only if they lose the electron. So helium normally has 2 electrons. Helium is represented by 2He4, means 2 protons and electrons, 2 protons, 2 electrons, and 2 plus 2, that is 2 neutrons. 4 is 2 plus 2, and this is actually proton plus neutron, means 2 neutrons. Here we are not talking about neutrons, so we can erase that one. This 2 means atomic number is 2, means 2 protons and 2 electrons in neutral atom. So it is not hydrogen-like species because it has 2 electrons at the moment. To make it hydrogen-like species, we need to remove 1 electron. If we remove 1 electron from this one, it will become He plus. It will gain 1 positive charge. Why? Because earlier there were 2 protons and 2 electrons, means plus 2 minus 2, total charge was 0. But after losing 1 electron, you have 2 protons, only 1 electron. So total charge is plus 1. So that's why plus charge here. This He plus is hydrogen-like species because it has 1 electron only. Is that clear now? What I am talking about?
Yes, sir.
Similarly, lithium, to become hydrogen-like species, it has to lose 2 electrons because it has 3 electrons. Lithium has 3 electrons. After losing 2 electrons, it will gain plus 2 charge, and then it will become hydrogen-like species.
और they are so मतलब फिर ये तभी हाइड्रोजन लाइक स्पीशीज है न्यूट्रल स्टेट में नहीं है आफ्टर गेनिंग और losing electrons.
After losing electron only.
So which means lithium 2 plus is not its general state, no sir, because it can lose 1 electron to obtain that, sir, maximum number of electrons in its outermost shell. So sir, in that case, lithium should be 1 plus, no?
Don't get confused with Lewis structure and octet rule. Here, basically, we are talking about it is in ionized form, in any ionized form.
Oh,
We are
okay, sir.
talking about
Okay,
that
sir.
ionized form in which it has only 1 electron, means it becomes similar to
E-
hydrogen.
सर हमें इन्हें
Okay,
नोबल नहीं करना है हाइड्रोजन लाइक की तरह.
Yes, only hydrogen-like species.
So मतलब जरूरी नहीं है octet state में हो sir.
No.
It could be, it's just with respect to loss of 1 electron only.
Loss of electrons so that it has only 1 electron.
Okay,
Loss
sir.
of electron can be 1, 2 electrons, 3 electrons. For example,
But the
beryllium will
remainder
lose
of
3
electrons is 1, sir.
Number of electrons in the atom in ionic form, obviously, in this case, will be 1.
Okay, sir.
All these will have
Okay, sir,
only
understood,
1
sir.
electron, not more than 1 electron.
Okay, sir.
Next, what Bohr has given the radii for hydrogen-like species. So earlier we have talked about it was 52.9 n square. This was R naught or A naught. Okay. But here you have Z in the denominator. To understand the difference in case of energy, Z square is in the numerator. In case of radius, Z is in the denominator. And because it is a number, it doesn't have any units. It can be in the numerator, it can be in denominator, it can be square. It hardly matters because it's just a number, atomic number. If we are talking about helium, this atomic number will be 2. For lithium, 3, beryllium, 4. Normally up to beryllium, we will be talking about, because boron losing 4 electrons, it is very difficult for boron to lose 4 electrons. It will require a lot of energy. So up to beryllium only. You need to memorize these formulas. This is something related to your NEET and JEE. Velocity of an electron moving in an orbit is given by V equals to V naught Z by N, where V naught is 2.19 into 10 power 6. Quite a few objective type questions have appeared in past years related to this formula.
Sir, is it again for hydrogen like species? This
Yes.
formula.
Yes.
Okay, sir.
For hydrogen, Z will be 1. For others, it will be 2, 3, 4. So write these formulas and memorize today only. Tomorrow you have to solve an assignment. Then another point, again, this is related to competitive examinations. If you are to calculate the number of revolutions
तो ये
made by
book का नहीं है?
electron, come again?
मतलब ये NCERT की बुक का नहीं है, CBSE?
No, no.
So please show
if
the
you-
previous slide once.
Sir, can you tell the value for V naught, sir?
2.19 into 10 power 6 meter per second.
Okay, sir. Thank you, sir.
If you have to calculate how many revolutions in an orbit electron will make, okay, then it can be calculated by velocity divided by the circumference.
So,
Yes.
can, like in school exams, can the derivation of like Bohr model come?
No, CBSE, since 2014, CBSE has given clear guidelines to teachers that derivations should not be asked in chemistry. Okay, but because your teachers are free in 11th, it does not happen in 12th, but in 11th, your teacher is your God, can do anything. CBSE can't challenge. The point here is those are the guidelines only, what CBSE says. And that's why most of the schools follow, at least the, schools like APJ, MET, DPS, these I have seen that they follow. Modern, the Mayur, these schools follow those guidelines, but a few schools I have seen, for example, East Point, and then one more, the new name I forgot, the previous name was Star.
Alcon.
Alcon has started following now. Okay. So they are doing better now. So those schools I have seen that they have asked derivations, but derivations must not be asked as per CBSE. The student has not to be tested on the derivations, rather on application-based knowledge, fact-based and application-based knowledge. Okay. So very low possibility that derivations will be asked in chemistry.
तो सर मतलब जो डेरिवेशन के बाद जैसे एनर्जी और वेलोसिटी वगैरह का एक्सप्रेशन आता है तो वो डायरेक्ट भी नहीं पूछेंगे ना?
That is something you have to just directly write the formula, substitute the values, get the answer.
Yes, sir. Okay.
So this is in 1 second, how many revolutions the electron will make. So this is given by V divided by 2 pi r. And if you see, the unit of velocity is meter per second, and unit of circumference will be meter. Meter will get cancelled. The unit will be per second. It means number of revolutions per second. It is actually the frequency, not the frequency of the radiation. Remember, it is frequency in terms of how many cycles, how many revolutions.
Cycle of the revolution.
Yes, per second. So this formula is used directly in objective type questions, multiple type choice type questions in both JEE and NEET. important from that perspective. So just a recap what we have done, and here I will be explaining a bit complex thing. And remember, uh, from this section, there is just one question which appears, okay? Or you can say two questions. And those questions, you just need to remember the answer. This is just for information that I am explaining this. Otherwise, the chapter will not be complete. When we say that the line spectrum of hydrogen as per Bohr model is that whenever electron moves from any higher state to lower energy state, it releases energy. Okay. So if it falls on first orbit, there is some range of energy. If it falls from any higher orbit to second, there is another some range of energy. Now, why these lines are there? These actually explain what Rutherford's model could not explain. When we are talking about the drawbacks of Rutherford model, one of the drawbacks was that it was not able to explain the hydrogen spectrum, lines on hydrogen spectrum.
Actually, he also focused on particle nature, not on wave nature.
Yes, yes. So here we have two examples. First is we have the emission spectrum, and the other one is absorption spectrum. The difference is based on what source we are using. If we are using a source which emits a particular frequency, okay, then it is emission spectrum. If we are using a source of white light, means everything is there, then it will absorb some frequencies here. So this is a system. Then this is known as absorption spectrum. Not, don't just get scared of this experiment. This is very simple. What happens here? We have hydrogen and we have it excited by providing energy. So hydrogen in excited state. And you know, when it is in excited state, the electrons will move to higher orbits and then will come back also. When they come back, they will release energy. That's why this diagram is there. So when hydrogen gas is excited, the electrons move to higher energy states, and after that, they come back to lower energy states. When they come back to lower energy states, they release energy as per Bohr's model. And when they release energy, these energies are of specific wavelengths only, depending on what is the transitions. For example, this one will have a specific wavelength, this one will have another wavelength. So each transition means movement of electron from one orbit to another orbit. These will have some specific wavelengths. Related to their energy. Okay. Similarly here, 1, 2, 3, 4, these will have a specific wavelength. So they will release some energy. So each line corresponds to release of energy because this is transition from higher energy state to lower energy state. So those energies are separated by a prism so that we can clearly see. Otherwise, we will not be able to see these. So these related to this part only because this is something we can see. We cannot see all the frequencies. We cannot see ultraviolet region. We cannot see infrared region. So I'm only considering this part because here we can see. But still here, if we use prism and we get these energies separated, when I say energy separated means the light separated this through prism, we only see specific bars only, not the spectrum, continuous spectrum. Okay, we don't see the continuous spectrum from violet, indigo, blue, green, yellow, orange, red. We don't see. Rather, we see only few bars. These bars actually correspond to the transitions. Which transitions? In this case, these. So because there are only specific transitions in visible region, only those frequencies are visible. So the radiation actually does not have all the frequencies. So here, when hydrogen sample is excited, it does not have all the frequencies, or it does not emit all the frequencies, because the electron falls from one specific orbit to another orbit, and that corresponds to only a specific frequency. Not all the frequencies are emitted, only specific frequencies are emitted, because electrons can move from one orbit to another orbit in some defined manner only. So if electron moves from fourth to 12th, fourth to second, some specific wavelength will be there, and that will always be same for hydrogen. If it moves from fifth to second, then another wavelength, and that will be specific. So all those bars will be visible on the spectrum. So that's why we see only bars, not the continuous spectrum, because there are only defined, definite transitions. Not all the transitions are possible. Now this one, absorption is just opposite of the emission spectrum. Here we have all the wavelengths. White light, white light has all the wavelengths in the visible region. Then we have some mechanism, and this is physics here, which absorbs some frequencies, which absorbs some frequencies. And if some frequencies are absorbed, only those frequencies are missing. So if you see here, we have dark lines. These are missing frequencies. Why these are missing frequencies? Because these were absorbed by this sample. So for your understanding purpose, emission spectrum is that one in which only particular frequencies are emitted. Those are captured on the spectrum plate. In absorption spectrum, the source emits all the frequencies in the visible region, but few frequencies are absorbed by a sample. Only those frequencies are missing on the spectrum plate. Why? Because those frequencies were absorbed by the sample. That's why absorption spectrum.
Sir, when the absorbing sample absorbs the frequencies, sir, is it necessary that those frequencies are of the visible range, or it could be of any random value, sir?
Any other values. Otherwise, those here, because okay, because it has white light, whatever will be absorbed will be the visible region only, because the source we are using is of white light. Otherwise, if we use another source, then it can absorb other frequencies also. But in this particular case, only visible region.
Okay, sir.
Okay. Now, I can give you just a hint that how it can absorb energy. For example, we have hydrogen gas here. Suppose this contains hydrogen gas. When white light passes through it, the white light will excite the electron. White light will excite the electrons of hydrogen atom. And again, electron will be excited from n equals to 1 to some other orbit. It cannot be that it can be in any particular orbit. It will be only either in 2 or in 3 or in 4. It cannot be in 2.5, 3.5, 3.1. Either it will be in 2 or 3.
Yes, sir, integral orbits.
Integral values. Only specific frequencies will be absorbed. Why it will be absorbed? Because hydrogen electrons are excited. And that's what I told you, that if you provide energy to an electron so that it can move outward, in this case, it will absorb energy. It will absorb energy. This electron will absorb energy, and
So
then it
from
will
the
go
white
to higher
light.
energy state. Come again?
Sir, the absorption of energy, sir, then occurs in the source of light, due to
No,
which the
not source
atom.
of light. In absorption sample. In absorption sample, we have hydrogen. So
Yes, sir.
hydrogen electrons absorb that energy from the white light,
Yes,
and
sir. That is what I was saying, sir.
only
Yes, sir.
specific energies will be absorbed because it
Yes, sir.
needs only specific energy to move to
Yes, sir. To
other
move to a
orbit,
certain orbit. Okay,
right?
sir. Yes, sir.
So few frequencies will be absorbed here. Those will be missing from the spectrum. Those will not be displayed on the output. That's why it is absorption spectrum. No detailed question will be there. Only concepts can be asked. What I have explained, only those concepts can be asked, that lines will be visible or missing. For example, in emission spectrum, only specific frequencies will be visible. In absorption spectrum, specific frequencies will be missing. In case of emission spectrum, we use excited sample. In case of absorption spectrum, we use white light source and some absorption mechanism which absorbs some particular frequencies which are missing from the output. Prism is just to separate, have the gaps between the bars. Just a recap what we have done. Lyman series is in ultraviolet region, Balmer visible region, Paschen bracket and fund are in infrared region. This is asked, so you have to memorize these values. Wave number, you know, is given by 1 by lambda. We have done it in previous class. It is given by, in case of transition. Okay. In case of transition from n equals to 1 to n equals to 2. It is given by 109677, 1 by n1 square minus 1 by n2 square. Here, this one is Rydberg constant. And remember the unit, if you are using 109677, the unit is per centimeter. If you are using 1097 into 10 to the power 7, then it is per meter. Same. Only the unit is different. One more important point when you are calculating wave number, and that is important. Wave number is just a number. How many waves in 1 centimeter, for example, per centimeter? So in 1 centimeter, how many wavelengths are there? This can never be negative. So if it can never be negative, this will always be lower orbit, and this will always be higher orbit in this formula. In wave number formula, n2 is always greater than n1. Whether the transition is from first to fourth or fourth to first, you will apply same formula. N1 will be 1, N2 will be 4. So it does not depend on the transition direction. N1 will always be less than N2 in this formula. And the reason is wave number can never be negative. So if N1 is 1, 2, etc., N2 will be N1 plus 1, N1 plus 2, etc. So N2 will always be greater than N1. Or if it is per meter, I have already told you. Okay. This is Rydberg constant. For Balmer series, this one will be 2. N2 will be 3, 4, 5 because it will always be greater than N1. For Paschen series, for example, it will be 3. N1 will be 3. Bracket series, N1 4, N2 will always be greater than N1. In that case, if this is 3, N2 can be 4, 5, etc. Now, sometimes this question is asked, and it is very common, that how many total spectral lines will be there? So for example, if we talked about transition from n equals to 4 to n equals to 1,
We can
the
calculate the formula, sir. N minus 1 by 2.
yes, that is
Sir,
formula when,
n bracket में n minus 1 divided by 2.
yes, that is formula when we are talking about only transition to 1. Okay, but
Yes, sir. It
there
is
can be
it is
transition
formula.
from n equals to 6 to n equals to 3 also. Okay, so we need to calculate how many total number of lines transitions are possible. So if electron is at 4, it can first come to third and then third to first. This is one possibility. Or it can come fourth to second and then from second to first. There are various ways. So total possibilities here, if you see 1, 2, 3, 4, 5, 6 spectral lines are there. Similarly, if the transition is from fifth to first, there are 10 spectral lines. For this, there is a formula. The formula is number of spectral lines equals to n2 minus n1, then n2 minus n1 minus 1 divided by 2. This formula is applicable to all transitions, whether it is from 6 to 1, whether it is from 6 to 3, 6 to 2, or from 7 to 5, where n2, for example, I am considering the transition from n to 7 to n1, 2. So you will substitute the values here. You will get 7 minus 2, then 7 minus 2 minus 1 divided by 2. Then, okay. And if you want to calculate in this region from 5 to 1, so 5 minus 1, 5 minus 1 minus 1 divided by 2, that is 4 into 5 minus 1, 4,
3.
3 divided by 2. No,
So 6.
no, it is not 6. There is something wrong. There is something wrong because it is applicable for both.
So because it is plus 1. N2 minus N1 plus 1.
Plus 1, it is plus 1. Yes, there is a mistake. So n2 minus n1, then n2 minus n1 plus 1 divided by 2, that is 4 into 5 divided by 2, 2 into 2, that is 10. So here it is plus actually, which is a misprint. And it is applicable for all transitions. You can note down the formula.
Sir, are you identifying N2 and N1 from these two figures given on the left side?
No, there can be any. So you
Okay,
can be
sir.
asked from 7 to 1.
Okay, sir. It depends upon the question, sir, the value.
It depends on the question.
Okay, sir.
How many spectral lines will be there? So you are calculating these number of these lines total transitions possible.
Yes, sir.
Then obtaining energy equation from Bohr's model. Energy, you know, in Bohr's theory, energy is given by minus RH 1 by n square. You know this is the formula in case of Bohr's energy model.
Stationary. Sir, for stationary, no?
For stationary state means for one orbit.
Yes, sir.
Energy of electron in a particular orbit is given by En equals to minus RH 1 by n square. So if we have to calculate the difference in energy gap, it will be E final minus
Yes,
E.
sir. We did it there itself, sir. I guess when we were discussing about it.
And we found the formula delta E equals to RH 1 by n initial square minus n final square. And when we substitute the values, it is 2.18 into 10 power minus 18 in joules, 1 by ni square minus 1 by n final square. Now, very important here it is, you have to consider this one as initial, this one as final. If transition is from first orbit to fourth orbit, then E1 is initial, E4 is final. Means Ni is 1 and F is 4. But if transition is from fourth orbit to first orbit, then Ni is 4 and F is 1. And you have to be very cautious here. Otherwise, the sign of the energy change will not be correct. Okay. In few books, it is given as minus 2.18 into 10 to the power minus 18, 1 by nf square minus 1 by ni square. That is correct because the position here, it is minus, and the position of ni and nf have changed here. In first case, ni you have here. In second case, you have ni here. So that is same thing. Whatever way you want to remember, but you should remember the correct formula. So in this formula, it is very important to note down which one is initial orbit, which one is final, from where to where. In case
Sir,
of
so
wave
when
number,
delta, sir,
okay,
sir, here as you wrote the this equation, sir. So in this, the value minus or plus will come according to the values put in Ni or Nf.
yes. So
So
that's why it is
yes,
important whether energy is being released or energy is being absorbed.
yes,
You
sir.
will get with the sign. So whatever sign it is, if it is plus sign, it means energy is being absorbed. If it is
Yes,
negative
sir.
sign, energy
And
is
sir,
being
I is
released.
less than F in the case of absorption, no?
Ni is less than, yes, Ni is less
Okay,
than
sir.
Nf in case of
Yes.
absorption.
Okay, sir.
So you need to be very cautious here. In case of wave number, Ni was always less than Nf. Okay, N1 was always less than N2 in case of wave number. But here you have to take it accordingly as per the question. Now question. Calculate the energy associated with first orbit of helium ion. It is hydrogen-like species. What is the radius of this orbit? So for this, you need to just write the energy equation with atomic number of helium. So energy En is given by minus 2.18 into 10 power minus 18 z square by n square. This is the formula I wanted you to remember. Okay. Very common mistakes done by students because in stationary state energy, there is negative sign here. Sometimes students write this formula with a negative sign. So remember, if you are writing in this form means this is initial and this is final. There is no negative sign with 2.18 into 10 power minus 18. No negative sign here. This is common mistake. So you have to be cautious. However, if you are talking about just the energy inside the atom is always negative, then there will be negative sign. Substitute the values for helium. Atomic number is 2. And you have to calculate for first orbit means n is 1. When you substitute these values, you get the answer as minus 8.72 into 10 power minus 18 joule per atom. Because it is negative, it means what is happening? It is more than, sorry, it is minus 8.72 into 10 power minus 18, whether it is more than the energy of hydrogen atom first orbit or less than.
So more than.
Okay, what is the energy of first orbit of hydrogen?
minus 2.
Minus 2.18
minus
into 10 raised to
2.18.
power minus 1.
Yes, sir.
So minus 8.72 into 10 power minus 18
Oh,
is more
sorry,
than
sir.
this.
Sir, hydrogen is greater than.
Sir, won't we use the formula n square a naught for this case, sir? In
That
with
is for radius.
hydrogen.
That is for radius. I'm talking
Radius.
about the energy.
Oh, okay, sir. Energy.
Okay, so for helium atom, okay, helium ion basically, it is minus 8.72 and minus 8.72 to 72 is actually less than minus 2.18.
Yes, sir.
Absolute value is more, but otherwise it is less than that. Then radius, for radius you apply the formula. Now for radius, the z is in the denominator. Substitute the same values n equals to 1 because you have to calculate for first orbit. For helium, atomic number is 2. When you substitute the values, you get 0.02645 nanometer. Because this one is in picometer, you can convert it to nanometer, or even if you leave it here, it is correct. But if question asks in a particular unit, and sometimes question will be mentioning that you need to write answer in particular units, then you will convert it.
Sir, just before you told us about Rydberg constant, sir. So here, sir, in this formula, sir, we aren't using that, no, sir, in this formula because R is still involved.
Here, this is Rydberg constant.
So, its value was something like 10967. Sir, what was that?
That was
then?
for wave number. Only for
Okay, sir.
wave number.
Only for, okay, sir. Okay, sir. Okay, sir.
Next question. What are the frequency and wavelength of a photon emitted during a transition from n equals to 5 to n equals to 2? Means an initial is 5 and final is 2. Frequency and wavelength you need to find out. For that, there are two ways. You can apply formula directly also. There are direct formulas also. Other way around, you can calculate delta E, and then you can apply delta E equals to h nu to get the frequency. Yeah. And wavelength, you know that wavelength you have, once you calculate frequency, nu equals to c by lambda will give you the wavelength. Otherwise, you can calculate wavelength from the wave number formula also. From here also you can calculate wavelength. So there are various ways you can calculate wavelength.
So,
Yes.
sir, in exam for approximation, can we take that 109677 as 1.1 and 10 to the power 5?
Well, I would suggest that for calculations, don't do that, but you should always do that if it appears as objective type question.
Okay, sir.
If it appears as objective type, then this is a better way to do it. And you will get the answer quickly.
Okay, sir.
So how to solve such questions? There are various ways. Well, you can just apply the formula of delta E, substitute the values. Ni is 5 and final is 2. Once you get the value of delta E, apply delta E equals to h nu. Okay. Now remember, because it is negative, it means it is energy emitted. So you will get sign accordingly from the formula. Then you will apply these formulas. Nu equals to delta E by h, because delta E equals to h nu as per Bohr's model. So from here you can calculate frequency. And once you get the frequency, you get lambda equals to c by nu, because nu is equal to c by lambda from here, and you get the wavelength. Otherwise, you can directly apply the formula 1 by lambda equals to nu bar wave number equals to 109,677 1 by n1 square minus 1 by n2 square. I don't suggest that you use that formula because that will waste your time. Rather use just this formula. Yeah. Yeah. So you will get 434 into 10 power minus 7, which will be 4.34 into 10 power minus 7, which will be 434 into 10 to the power minus 9 meters, which will be 434 nanometers. Because 1 meter is equal to 10 to the power 9 nanometers, or 1 nanometer equals to 10 to the power minus 9 meters. Next question, calculate the wave number for the longest wavelength transition in the Balmer series of atomic hydrogen. Now,
So
very
here,
important point.
here, sir, longest wavelength is lowest energy.
Yes, correct, good. Delta E is hc by lambda, means energy is inversely proportional to wavelength. If this one is longest, means largest, this one will be smallest. Okay. So transition will be smallest, means n equals to 2 to n equals to 3. So longest wavelength transition will be the shortest transition. And this is something you need to memorize. Don't try to find it during the examination. You should already know that longest wavelength transition is the smallest transition itself. So because we are talking about Balmer, and Balmer series will be when it is n equals to 2. So this is n equals to 1, this is 2. So the transition from second, the shortest one will be to the third one.
So that's the final one.
Yes. The shortest transition is from Balmer, for Balmer series is from n equals to 2 to n equals to 3. Substitute those values. Okay, why I am saying n1 equals to 2 and 2 and final equals to 3, as I told you that for wave number, n1 will always be less than n2. So even if transition is happening like this, from fourth, from fifth, yeah, n1 will be 2, n2 will be 3, 4, 5, etc. for this wave number formula. And this is something students make mistake very frequently.
सर मतलब इसमें किसी भी कंडीशन में n1 is always smaller than n final.
Yes. Means you need to remember in the way that for n1 is always 2 for Balmer series, n1 is always 3 for Partian series, n1 is always 1 for Lyman series, like that.
Okay, sir.
Substitute these values, you will get the wave number. Longest wavelength transition is the shortest transition. It will be 1.5 to 3 into 10 power 6 per meter. So remember, I have used this one, 1.097 into 10 to the power 7. You can use 1.09677, but avoid to use it. You can approximate. The third decimal place can be approximated. Okay?